In this video lesson, we are going to study nucleophilic addition reaction of cyanide ions to aldehydes and ketones to form hydroxynitrile. The reagents we will definitely be using for this reaction, you could either use sodium cyanide or potassium cyanide and dilute sulfuric acid at room temperature and pressure. Of course, the mechanism of this reaction is nucleophilic addition. Remember that this reaction will always result in hydroxynitrile. And that hydrogen cyanide is not used alone because it is poisonous. Hydrogen cyanide is not used alone because it is poisonous. The only way we can get hydrogen cyanide will be by reacting sodium cyanide or potassium cyanide and dilute sulfuric acid. In the reaction vessel, the reaction will generate a hydrogen cyanide. The reaction will generate hydrogen cyanide. Again, the aqueous solution in the reaction vessel will contain hydrogen ions. These hydrogen ions are generated by sulfuric acid. It could be from water, or it could be from the hydrogen cyanide. In the same aqueous solution will have some free cyanide ions. Before we continue with our topic today, please like this video and subscribe to our channel. Do not forget to hit the notification bell. As we discussed in our previous video, the polar nature of the carbonyl carbonyl group, the polar nature of the carbonyl group in aldehydes and the ketones enable them to undergo nucleophilic addition reaction. You see the carbon bonded to the carbon double bond oxygen. Because of the difference in the electronegativity, electronegativity between carbon and oxygen, oxygen will carry a partial negative charge, while carbon will carry a partial positive charge. As I said, we cannot use hydrogen cyanide alone because it is poisonous. So in that case, we will have to use, the reagent that we'll have to use would be sodium cyanide or potassium cyanide with dilute sulfuric acid. In the reaction vessel, when these two are mixed together, the aqueous solution will contain the hydrogen ions, which could be generated from the from water. It could be generated from the dilute sulfuric acid, or it could even come from hydrogen cyanide. Because hydrogen cyanide being used alone is poisonous, this reaction between sodium cyanide or potassium cyanide and dilute sulfuric acid will generate hydrogen cyanide. It is this hydrogen cyanide that we are going to use in our reaction. So this is how the reaction is going to is taking place. Reaction, a nucleophilic addition reaction of cyanide with ketone. Let me start with ketone. With ketone. Okay, with ketone, let me say propanone. You will have propanone here. With ketone, this is how you can find it. Plus the hydrogen cyanide that have been generated from the reaction vessel. We will have propanone, and we will have our product will be as we initially said. This reaction will always will result in this reaction will always result in hydroxyl nitrile. Hydroxyl nitrile. So when ketone reacts with hydrogen cyanide, the hydrogen cyanide that have been generated from the reaction of sodium cyanide or potassium cyanide and dilute sulfuric acid, the hydrogen cyanide will now be used to react with the ketone, and the result will be a hydroxyl nitrile. And in this case, we use propanone, and our result is 2-hydroxyl 2-methyl propane nitrile. An important thing in this reaction is that it results in the addition of another carbon atom into the carbon chain. It results in an addition of one carbon atom into the chain, and it also results in the formation of a nitrile. Another organic compound results from it. So now, this is the reaction. This is the reaction of this. This is the chemical reaction you can find. But it should be recalled that if a nitrile like this one, it should be recalled that if a nitrile like this one, is heated under reflux, if a nitrile like this one is heated under reflux with a dilute acid such as dilute hydrochloric acid, a corresponding carboxylic acid is formed. I said if a nitrile such as this one is heated under reflux with dilute acid such as dilute hydrochloric acid, a corresponding carboxylic acid is formed. I just want to give you an example of this type of reaction here. so that you can be used to it. Let me say, I said if a nitrile is heated, for example, I want to say this one. This one is ethane nitrile. Ethane nitrile is CH. CH, CAN, we will have CH3, COOH, CH4, NH4, sorry. The condition we will have, this is this is an acid hydrolysis. Acid hydrolysis, let me already here, acid hydrolysis. Acid hydrolysis. So we have a reaction like this. We can always have a corresponding carboxylic acid. Ethane nitrile is hydrolyzed under acidic condition, will give us ethanoic acid. So that's what I'm saying, that if any nitrile is heated under reflux with a dilute acid such as dilute hydrochloric acid, a corresponding carboxylic acid is formed. And I am using ethane nitrile as our example. Ethane nitrile as our example. If it is hydrolyzed under acidic condition, we will have ethanoic acid. Let's move straight away to the mechanism of this nucleophilic addition reaction of this cyanide ion to the ketone. The reaction above, I want to give you the reaction, how the mechanism, how it takes place. Let's go to the mechanism. Okay, in the mechanism here, I said that the cyanide ion is generated by hydrogen cyanide. So step number one in this mechanism, will be what? Step one. In step one in the mechanism, the nucleophile attacks the electron deficient carbon. The nucleophile attacks the electron deficient carbon. The nucleophile which is the cyanide ion, does what? Attacks. The nucleophile attacks the electron deficient carbon. The electron deficient carbon. The electron deficient carbon, or we'll call the partial positive carbon. Electron deficient carbon. Okay. The electrophile, which is the cyanide, will attack the electron deficient carbon, or we say the electrophile which is the cyanide, is attracted towards the partial positive carbon. But what do you understand by an electrophile? What do you understand by an electrophile? In our previous video, we did mention that an electrophile is an electron pair donor. An electrophile is an electron pair donor. And secondly, what do you understand by nucleophilic addition in organic reaction? Nucleophilic addition in organic reaction is a mechanism. This is a mechanism in organic reaction in which a nucleophile attacks the partial positive carbon atom. The nucleophile attacks the partial positive carbonyl carbon atom, and the addition across the carbon oxygen double bond will now occur. How is this going to attack? Let's see how the thing goes. I said initially the reaction above is with propanone. Now, let me draw the structure for you to better understand. This is propanone. This is propanone. We have a CH3 here. This is a CH3. Of course, the reaction. Now, their charges. This is a partial negative, and this is a partial positive. And I said because the polar nature of the carbonyl group in the ketone enables it to undergo nucleophilic addition. This is the carbonyl group is polar. So what happened? Here you will see that the nucleophile, they say the nucleophile, which is a cyanide. This is the nucleophile. This is the nucleophile here. As I said, a nucleophile is an electron pair donor. So when the nucleophile attacks the electron pair, the electron deficient carbon, now you have to use the curly arrow to show the movement of the lone pair of electron on the electrophile, on the nucleophile, sorry. That shows the nucleophile attacking the partial positive carbon, the carbon of the carbonyl group. As it is attacking it, what happens? There is movement of this bonding electron towards okay, let me use this. Let me represent it using another arrow. That is what is happening there. This lone pair of electrons on the nucleophile are approaching this partial positive carbon. The electrons here are being shifted towards, they're doing what is repulsion. They are pushing the electrons, the bonding electrons here towards what? Towards the electronegative oxygen. And this result in what? In the ion that I am going to write here. This is the ion that results from this reaction. We will have a CH3 to the carbon. There will be a CH3 oxygen is there. The cyanide now comes here. Now, oxygen has acquired, electrons here were pushed towards the electronegative oxygen. Oxygen has acquired extra electrons. Oxygen now has this the electrons here. It has acquired extra electron, indicated here by the negative charge. So this is an intermediate that has been formed. This is an intermediate that has been formed. We call this an intermediate. This is an intermediate that has been formed as a result of this mechanism. Now, the intermediate is highly reactive. The intermediate is highly reactive. So what must be done? Something must be done. Now it takes us to step number 2. Step number 2. Step 2. Step 2. In step 2, the highly reactive intermediate does what? It is unstable. It is highly reactive. So something must be done to stabilize it. It has to grab what? The hydrogen ion. So we say the negative ion form the negative ion. The negative ion formed then picks up a hydrogen ion it picks up a hydrogen ion from the solution. It picks up hydrogen ion in solution. The negative ion form, which is the intermediate, picks up a hydrogen ion in the solution. And this hydrogen, as I earlier told you, the hydrogen ion in the solution could either come from, in the aqueous solution, when the reactants they dissociate in the aqueous solution, they will release hydrogen ion, and this hydrogen ion could either be from where we said it could be from the hydrogen cyanide, or from water, or from sulfuric acid. So when this happened, that we are on step 2 now. We are on step 2 now. After the intermediate is formed, the intermediate, which is highly reactive, it is very, very unstable. And in order to be stabilized, what happens? The negative ion formed then picks up a hydrogen ion in solution from that may come from hydrogen cyanide when it dissociates. It could come from water. It could come from the dilute sulfuric acid. And this is how the mechanism of the second phase will go. In the second phase, this is what we are going to see. We will have the CH3 now. This is the hydrogen cyanide. Remember, this is what is happening here. So precisely, the intermediate will grab the intermediate, or the negative ion will then pick up the hydrogen ion. The hydrogen ion. So in this case, the hydrogen ion is coming back from hydrogen cyanide. It picks up the hydrogen ion, and this is the resultant product that will come about. So this is the product that is being formed. We can summarize this. We can summarize this in a 3-step, in one reaction, which will be just a summary of this could be written here. A summary reaction could be in this form. I will have then it will result in this is a summary reaction. Where we have the cyanide here, top there, then again, or maybe I can replace this with this water one. Let me use green. Green is more preferred. All right. partial positive, and this is partial negative. We have this is a hydrogen ion. Is picked up by the negative ion. And this is the resultant product that is formed. This product could equally be written as you can still write this as CH3 C the cyanide and well, we will have so we can call this compound. I said we can call this compound. Let me write it again. So we can call this compound 2-hydroxy-2-methyl propane nitrile. 2-hydroxy 2 methyl propane nitrile. That is this is a carbon atom. I mean, this is the product of our nucleophilic addition reaction. So once more, we have done that with the ketone. We started, I showed you the chemical reaction. Step 1, the nucleophile attacks the electron deficient carbon. An intermediate is formed. The unstable and reactive intermediate, that is the negative ion, picks up the hydrogen ion in solution from cyanide. If the cyanide was not there, it could be from water, it could be from hydrogen, from dilute sulfuric acid. And that is what is happening. In this case, it is from the cyanide. That is what is happening. It picks up the hydrogen ion here from the cyanide. Now, this is the product that is formed. And the cyanide ion is generated. Now, that is the product that is formed. I now summarize it using a single reaction. We have the propanone there, nucleophilic attack. You see the movement of the electron pair to the partial positive carbon. Then an electron pair to the electronegative oxygen. See the bond, an intermediate is formed. This is an intermediate. This is an intermediate that is being formed here. That intermediate now picks, the intermediate now picks a hydrogen ion in solution. And finally, this is a 2-hydroxyl 2-methyl propane nitrile is formed. Yeah, 2-hydroxyl 2-methyl propane nitrile is formed. So that is the product. Now we now go with nucleophilic addition reaction with aldehydes. We now go with aldehydes. See what is happening with aldehyde. Our example with aldehyde is I want to use ethanol as our example. I want to use ethanol as our example. Here you will have, this is ethanol. I said the hydrogen cyanide is generated from the reaction vessel. That is the hydrogen cyanide. This is the product that is formed. Firstly, in this reaction, when the aldehyde, the ethanol, is added to the hydrogen cyanide, what happens? What will happen will be the hydrogen ion in solution. There is hydrogen ion in solution, and there are also free cyanide in solution. So there is the hydrogen which is here, and this is the cyanide which is here. The mechanism will show you how the negative ion is formed and how the negative ion will now pick up the hydrogen ion to form the nitrile, the hydroxynitrile. Now let me just go to the mechanism so that you will see what is happening there. You will see what is happening there. Let me just go to the mechanism. This is, the product here is 2-hydroxypropane nitrile. The product here is 2-hydroxypropane nitrile. Propane nitrile. Two-hydroxypropane nitrile. So that is the product there. 2-hydroxypropane nitrile. This is the product that is being formed as a result of this nucleophilic addition reaction on aldehyde. I want to show how the mechanism is going to take place. This is how the mechanism is going to take place. This is how the mechanism is going to take place. Okay, we will have I put it here again like this. Let me say this is our aldehydes. This is our hydrogen. This is our ethanol. So what is happening there? An intermediate is formed. Let me just, sorry. Here we have oxygen with a negative charge. Our nucleophile is supposed to be here, attached to this bond. The hydrogen was initially there. We will have H3C here. That is where this is the new hydrogen ion that was picked up, and finally the hydrogen that was initially there will be here. Now the cyanide, this is a cyanide that is in solution. The cyanide in solution has now movement of the bonds, the lone pair of electrons, nucleophilic attacked. Now there is movement, lone pair of electron here, I mean a bonding electron to this place, but this is partial positive and this is partial negative. That's how the whole thing is moving. Nucleophile attacks. Here I can can write in simple words, nucleophile attacks. Nucleophile attacks nucleophile attack on a partial positive carbon. The carbon that is partial positive. Nucleophile attack on this. Now, as you go here, I can say the negative ion picks up hydrogen ion. The negative ion picks up the hydrogen ion. The hydrogen ion from the cyanide. Now, the product 2-hydroxynitrile, 2-hydroxypropanenitrile is formed. 2-hydroxypropanenitrile is formed. Two-hydroxypropanenitrile formed. So that is how the reaction is going. Nucleophile attack on the partial positive carbon, then to form the negative ion. The highly reactive negative ion picks up the hydrogen ion in solution. Now there is the formation of 2-hydroxypropanenitrile. That is how the mechanism takes place in a nucleophilic addition of cyanide with the aldehyde. Our example was what? Ethanol. So now, from ethanol, we have noticed that from ethanol, we have gone now to what? To a 3-carbon atom. There is an addition of another carbon atom. And again, there is the formation of a nitrile. So this is an important reaction for chemists. Such a reaction is very, very, very important. Such a reaction is also very, very important when it has to do with isomerism. It's very important because it generates, this reaction is very, very important because it generates a chiral compound. It generates a chiral compound. You know that the chiral nature of a molecule brings about optical isomerism in any organic compound. When a compound has 4 different, the chirality in every compound is when a molecule has 4 different groups attached to the central carbon atom. And in this nature, or in this reaction, that is what has happened. This reaction has resulted in a chiral molecule in which the central carbon atom, which is here, has 4 different groups attached to it. We have the methyl group, we have hydrogen, we have the cyanide group, we have the hydroxy group, which is attached to the central carbon atom. And this usually have an asterisk. The central carbon atom has an asterisk on it, indicating that it has 4 different groups attached to it. This molecule brings about optical isomerism. We are, in other words, saying that such a reaction will produce a racemic equimolar mixture of isomers. It's going to produce a racemic equimolar mixture of isomers. And this does not happen in all compounds. It only happens in compounds, in carbonyl compounds that are on, excuse me, it happens in carbonyl compounds that are on symmetrical. Any carbonyl compound that is unsymmetrical and and has a trigonoplanar shape. For example, this ethanol is unsymmetrical and it has a trigonoplanar shape. It has a trigonoplanar shape. If we look at it here, there's a methyl group, there is oxygen, and there's hydrogen. It has a trigonoplanar shape, and it is unsymmetrical. So such a compound which is unsymmetrical and has a trigonoplanar shape will produce, when it reacts with a cyanide, the cyanide ion, when it reacts with a cyanide, the cyanide ion has equal chance of attacking it from above here and below. If this molecule is turned in, is rotated, if this molecule is rotated and it is attacked by this cyanide nucleophile, the cyanide nucleophile has that opportunity, or have equal opportunity of attacking it above the plane and below the plane. Let me just show an example on how this can happen. In a molecule like this, you will see this is let me say this is the carbon. This is partial positive, and this is partial positive, and this is partial negative. This compound and this compound here, I said, in a carbonyl compound that are unsymmetrical and is trigonoplanar in shape, the cyanide ion has equal chance of attacking the molecule from above and below the plane of the molecule. So here, see what I'm talking about. It could attack from this, from above, and it could attack from below. And if you attack from above and below, this is going to be the product. These are going to be our products, and this is likely going to just show you. I call this the mirror plane. I call this the mirror plane, or the mirror line. The structure here will be, it's a carbon, an OH, we have, let me say hydrogen here. Um, hmm. We have this one, CH3. Here we can see have the same carbon. OH. We will have the CN. We will have our hydrogen here. Uh, and we will have our methyl group here. Oh. So that is what I am trying to say. I call this I call this Once more, I am saying that such a reaction like the one above, because the ethanol is unsymmetrical and it has a trigonoplanar shape, the cyanide ion has equal chance of attacking it from above and below the plane of the molecule. So if we can rotate the molecule in this form, the cyanide ion has that opportunity of attacking it from below and from above. And if it does that, it is going to produce a racemic equimolar mixture of isomers, because the compound is going to produce a racemic equimolar mixture of isomers. Maybe for clarity, maybe again. So that is what is going to happen. So that's what is going to happen. Once more, we are doing nucleophilic addition reaction of cyanide ions to aldehydes and ketones to form hydroxynitrile. And we said the reagent could be sodium cyanide or potassium cyanide and dilute sulfuric acid. There was an important thing we mentioned, that the reaction mixture will generate the hydrogen cyanide. And because of the polar nature of the carbonyl compound, it can undergo nucleophilic addition reaction with the ketones and aldehydes. And these are the things we have gone through. Thank you for listening. Learners, if you haven't subscribed to our channel, please subscribe and hit the notification bell. We thank you for listening.